Welcome back, ladies and gentlemen. Today we're talking about scatter plots and specifically about identifying relationships. Let's get right to it. This problem is going to ask us to describe the relationship, so that's number one, between the data, and identify any outliers, that's number two, gaps, that's number three, or clusters, that's number four. So we actually have four things we're doing for two different graphs. We will do all four on both graphs. First of all, we're looking at describing the relationship. What I'm seeing is as I increase on the x-axis, I'm also increasing my y values. So generally, if I'm increasing, I'm going up and I'm going right. And if I can basically do this, notice how I'm increasing both. It creates kind of a line as I'm moving my left hand forward. It's almost like the y is being dragged or drug at the same speed. If it's doing that, it's increasing. You should know this from a positive slope as well. Same idea, if it increases from left to right or as x increases, so does y, then that is a positive relationship. So 1 is going to be positive for this graph. Next, we need to identify any outliers, gaps, or clusters. So outliers are the guys who don't really fit with anybody else. But we can't just look at a graph and be able to say it. We got to be able to look at different things. So as an example, as I'm looking at this graph, I'm looking for any outliers. Well, here's kind of a group of outliers. But really, while this can be outliers, this guy for sure is. So there's an outlier at x equals 70. As you go along, you'll be positive. Wow, I just noticed I spelled that wrong. As you go along, you'll be able to know that there are clusters of outliers, and that's what this one would be. But right now, we're mainly going to focus on just starting to recognize the idea of a cluster, or an outlier, sorry. So 2, there's an outlier at x equals 70. Or on the x-axis, where x equals 70 and y equals about 2250. Don't really want to estimate that much, so I'm giving just enough information to be able to get the same point across. Now, as we're looking here, we're looking for any gaps. If I'm going, I have to look at this two different ways. As I go along the x-axis, technically, it looks like I have a gap here and here because nothing is happening, because where I'm looking at on the x-axis, I'm looking up from the x-axis. The problem is we can't call that a gap because our data never actually started. Our data starts here, so we're going to be looking up as we move over, and I'm not really seeing any gaps. There is a gap here that we're going to address from the y-axis, but not from the x, because if this guy was brought down, they'd be pretty close, creating no gap. Same here, if they got brought down with the rest of the data, it'd be here, rest of the data here. So the only gap I see is from about right here to 70. So there is a gap on the x-axis. And what did we say that before? So it's at x, that starts, sorry, at 59, starts at 59 and ends at 70. Because it's going to start about here if I bring this point all the way down, and then it's going to end because there's a gap between this point and that point. If we brought them to where they're equal, there'd be a gap. Now, we've done the x-axis, and now we're going to look at the y-axis. There's not always a gap at x and a gap at y. There's not always a gap at x. There's not always a gap at y. And sometimes there's many gaps. These are the things we're looking for. So as I go along the x-axis, I'm actually looking over this direction to see if there's any kind of gap. And I notice that there's a gap from 500 to 1500. So on the y-axis, there it starts at, what did we say this was, 500? And ends at 1500. Then I go along and I notice there is another gap that starts about right here and ends about right there. So there's another gap on the y-axis that starts at about 2250 and ends at about 3000. So I'm just going to put 3000. And these two are close enough because they're basically 1 unit apart that I'm not going to count them as a gap. All right, so the last thing we have are clusters. So clusters is a group that's so close together they're either touching or very well could be if they moved at all. So there is a cluster right here. And then I can list the coordinates. I can say a cluster starts. So there is a cluster that starts about 25 and ends about, 32 on the x-axis. So let me put x-axis first, such that it starts about 25, maybe 26, we'll put 25, and ends about 32. Might be 33, but we'll put 32. All right, so that's the relationship on A. Over on B, we'll go a little bit quicker because we have less to explain, and now we're just hopefully getting the point here. So we hit the relationship. Well, I can't really tell what's happening as I go along X compared to Y because I'm kind of all over the place. When that happens, I call it the shotgun method. If you ever shot a shotgun at a target and you're far enough back, you'll notice the pellets just kind of randomly hit, and that's kind of what this looks like. So that means we have no relationship. And I think I'm going off frame here, and so I apologize if I do. But that says no relationship. Number 2, we're looking for any outliers. This is about the only outlier. Everything else is pretty well grouped together. So I'd say that there is an outlier at x equals 40. I could say at y equals 6 as well. I could put the coordinates 40, 6. There's a lot of different things we could do. Because remember over here, we didn't do all of it just because it was hard to tell on the left. 3, we're going to be looking for any gaps. There's gaps all over the place. So when there's no relationship, there's a gap. Well, actually, the only gap I really see now that I think about it, it looks like there's a bunch of gaps here. But again, the idea of a gap is if you bring it together, if I'm looking along X, there's no real gaps going that way. If I look along Y, there's no gaps going, if I look at X, there's no gaps going vertical. If I look at Y, there's not really any gaps going horizontal if I bring them all together, except right here. So the only gap is on the Y-axis. And it starts at 4 and ends at 6. And then 4, we're looking for any clusters. The closest we could really do is clusters. You don't really do clusters of 2. We could list those, but it's not really a cluster, so we just say none. So as far as relationships, outliers, gaps, or clusters, remember that relationships are positive, negative, nonlinear, or no relationship. Outliers, those are the ones that are pretty far apart from everybody else, usually more than 1 unit. And remember, 1 unit on a graph is 1 square, no matter how much is in between. So this is 1 unit here, even though there's $500 in between them. So that defines outliers. Gaps is anything that creates extra space. So a gap is here to here, here to here. Again, we could list a gap right here if we wanted to. So, well, we didn't on that one. Again, it's probably more than 1 unit, and that was within 1 unit. I say probably because when you get into higher level math, you're going to be using tools that clearly define according to math. And right now we're just doing a visual representation. And as far as clusters, I like to think of those like a closed fist. Basically, they're all held together and they'd be able to fit within a closed fist. Nothing would be coming out. I can't really fit all that in one closed fist. So while this is close together, it would not be a cluster. They're really going to be touching or just about touching. Like if I drew my pen here, they look like they're touching. At that point, I'd be covering all points. Now pause the video and copy what is on your screen into your notebook. Now that you're back, anytime you have to rewatch the video for clarity or to remember something, you need to write what you picked up into your notes. Use arrows, circles, shapes, pictures, whatever else you need, but add to your notes to make them yours. Lastly, always remember that you're in school, and when you're learning, it's all about understanding the process, never just about the answer. We'll see you tomorrow.